I am Amanjeet Singh and I work at mobile.dev, where our mission is to shift left on performance issues, not performance issues, mobile app issues, and to solve them proactively rather than you first release the bugs. So what I'll do today is I'll share with you some of the pitfalls which I faced when I started solving for platform issues. And I will also share a strategy which helped me, and with the help of that strategy, I reduced my app launch time in one of my previous companies by around 8%. And this strategy also fits in with another performance issues like battery and things like native crashes. So yeah, let's start. So what should we discuss first? What is performance? No, I'll not discuss what is performance. You guys are here, so I will hope that you will know what is performance. Let's start with a story. There is a developer. This developer works at a large scaling organization developing a mobile app. Spoiler alert, this is me actually. And the very first pattern that this developer notices that a scalable code base, which gets the organization like huge revenue, it is not going to be a high performant code base. Why? Because you are not going to upgrade libraries periodically. You are going to have partial quality gates. There is going to be one developer which got time from the feature work. He develops some of the quality gates, but the results are still noisy. Then, yeah, you are not going to scope Dagger dependencies very properly. Everything is going to be singleton. So, yeah, I love singleton. That's a sarcastic comment. You will select configs only on the basis of business. What is going to get you revenue? You will choose that, not thinking about how it impacts the health of the app. And then, as soon as this thing goes on, there is going to be burst of this bubble, and you notice this pattern too, which is that you get to know about all these type of issues from customers and Android vitals, which basically will affect your Play Store listing. And as soon as that happens, you will go to your product managers, you try to prioritize these things with your feature work, and it is going to be really difficult. Why? Because you are not going to be sure that how Okay. Yeah, so you are not going to be sure that how these performance issues are linked with business. They are not going to be very easy to explain for product managers, because you have to really tell what cold start means, what battery usage means, and deep technical terms. And then if you are able to do that still, it is going to be really difficult to actually quantify that how much time it will take to solve you for that performance issue. Now, with all of these questions, what happens is that this company will give birth to a platform team of, like, let's say company X. The very first mission of this platform team is going to be drafting OKRs for cold start, because that was the problem which they were facing. The objective definitely is going to be uplifting app quality of the consumer app. And because they were facing like many problems, so they try to fit in like three things: reducing cold start by 60%, wake locks by some X%, and frame drops by some like 50%. Now, frankly, this sounds very optimistic, and I have personally done that, but man, this doesn't work because you don't have observability on production. Without knowing what is happening on production, you'll not know what are the cases that are possible. You'll not know the worst case, and you'll not have quality gates. And because you not have quality gates, it is very much possible that the fix that you are going to attempt, either it gives a performance gain, or even it is going to be compromised with other feature work that you have. So pattern 4 emerges here, which is that drafting OKRs for a platform team, it is very difficult. So let's look at first few attempts by this platform team and how they were tackling this issue. The first thing that they did was look online for some of the blogs and how companies are solving it. So they started searching like reducing cold start by a company X by, let's say, 50%, and they started borrowing some of the fixes which they thought are applicable to them, and started playing with some of the tools which are famous in documentation or GitHub. I'll not name them, but yeah, they see some light, and they started pointing out to bottlenecks. then it is also very much possible that your team will have some of experienced developers where they will have some past experience and they will also try to change things accordingly with their experience. Now you ship it, and theoretically this works, can give you some of the gains, but does not guarantee you returns. Personally, I have kind of followed this and increased my cold start. So yeah. This is actually highlighted as anti-methodology by one of the well-known engineers I know from Netflix. I highly recommend you reading his book, System Performance book by Brendan Gregg. I'll also link back to one of the, I'm going to tweet it after this talk. I'll link that book. I would highly recommend that. So he speaks about anti-methodologies. First one is blame someone else anti-method, where when the performance problem is thrown at a team, they try to blame a system which they are not part of. Then a streetlight anti-method, which says that you'll see some light in some blogs and some documentation, and you try to solve it by identifying bottlenecks. And random anti-change method, which basically says that you will try to change things randomly here and there, see if that can provide you gains. So things were not working. It is very clear. So the platform lead asked himself and his team, what are we doing wrong here? And the very first thing he asked was, are we even chasing the right metric? Like, is the total time which we usually chase while benchmarking, is that the only thing we should chase for? Is there any case which we are missing, because when we fixed it, there was no change in our production metric? So is there any missing case that we don't know of from production? And maybe their fixes worked, but because there were some parallel feature work which was shipping in the same app version, it was compromised. Now, this time they didn't just directly jump on the fixes, they sit back and they strategize. The very first thing they did was identify proper metric, each and every metric which is related to cold start, and create observability directly from production. So first thing which this team realizes is that it is not only cold start which they care about, it is app launch. Now this is going to give you two advantages. First, the communication with product team is going to be easy. They know about app launch, but they don't know about cold start. Cold start, they think like something related to winters. So yeah, they don't know about it. Second thing is also that if you think from user perspective, this app launch can go beyond the first screen drawn time, which is theoretically defined by Google, and can even include like on start and on resume also. So since there could be different spans possible, one of them, which I said, like Google defines in their books, like from content provider to the first screen drawn time, and another one which can very much go beyond that first screen drawn time till on create end, or maybe include on start. So you have to keep an eye on each and every span that is possible. So what this team did was they started logging events and some of the attributes which are related to cold start. First was first screen name, then the total time which they were already caring about, and then the user ID. The ideal tool for this is Firebase Analytics, and what they did was they created an abstraction app launch tracker with a start tracking API. They started a system clock, and from content provider they were chasing till the end of the span, and till the end API was stop tracking, where they will pass the first screen name which they would know from activity lifecycle callbacks. And the attributes which they were logging were like this. If you have used Firebase Analytics, this is how they send the attributes. And if you guys are thinking that how we get the first screen name and details in how we can detect the first screen name through activity lifecycle callbacks, I will link back one of the like well-known PY blog in the same tweet, and I would recommend to like do that to detect first screen name. And you'll send the event, app launch event with these attributes. There is another advantage which I will want to speak about, and this is BigQuery. Because with Android Vitals, the problem is that it knows about cold start time, but it doesn't know how it links to your app. Like it doesn't know the first screen name. But with BigQuery, now what you can do is you can query the data and create the intelligence, which is directly related to your domain. So let's see our tracker, the project tracker. what we have till now. We have attributes from the app launch. We have insights from the data. And what the team did was they plotted a graph with the x-axis as the first screen name and the y-axis as the percentage distribution of the app launch. And what they realized, and this is like for one day, this keeps on changing every other day. What they realized that splash screen is not the only contributor. It is very much possible that first screen name is something different. What this means that app icon click is not only trigger for the cold start, it could be something else also, like for example, deep links. For example, if you are using the app in background and it was killed by the system, if you go back to the app, it will trigger a cold start and the first screen name could be different, which was at the time it was killed. Now, I will also share you one of the interesting things which this team found out. So it is about campaigns. When the business were sending the campaigns, they noticed that the graph of like the percentage distribution goes up for some of the deep links screen, and even at those days, splash screen was not like higher than the deep links one. So this keeps on changing, which basically tells us that you want to care about like different screens as well when you are solving for app launch. Let's look at the step 2. Meanwhile, the data is getting accumulated on production through that Firebase analytics. What you want to do is you want to stop bleeding by creating a baseline. Why you want to do that? Because now when you will have data, now you want to attempt the fixes. And when you are attempting the fixes, you want to you want to be ensured that you are not going to be compromised by the other feature work. Because otherwise it is going to be like a cat and dog race. You solve for it and maybe it was neutralized by, let's say, some other feature work and you don't know it, right? So you want to ensure that what is entering on your baseline branch, master branch, develop branch, whatever it is, the first thing that you want to do is the same observability that you are creating on your production, you want to create it on staging environment. And an ideal tool for this is which is going to be surfacing like tentative regressions, which is going to detect outliers and the noise that you can have because you don't want noisy results and want to have minimum false positives, and surface regressions in a way so that it is also going to be mapped to a developer back, because it is going to ease out the ticket creation, which product managers really do care about. And last would be infra to run the test, which is not really about like to just run the test. It is also about developer productivity, because you don't want to block the developers like forever and just like, okay, like you stop, you don't ship anything. You don't want that. So you also want to ensure that your infrastructure is resilient enough to run like large test cases. I will discuss about this point because at mobile.dev, this is personally like one of the challenging tasks when you are detecting outliers and noise. So noise and outliers can come through various factors. One of them is network, because when you are doing performance benchmarking with apps that talk to network, you don't want to consider real network because that is going to create noise in your results. How we solve that? We actually record all the API calls and replay them through a proxy server so that at the time of benchmarking, we are not talking to the real server, since it could like generate noise. Another source of noise comes from remote configuration, because if you are going to rely on real network, then you will not know that what type of config your app is really running on while benchmarking. So if you are cutting down the network, you can take things in your control. For Firebase, for example, it is this file which they persist in file cache. This file is containing all the activated configs which they have, which they resolve through package defaults, through real network or the static values. You can mock this file given that your network is being mocked. Then you don't want to profile on debug builds because why? First, you want to account for the changes that you have in ProGuard and the DexGuard. You don't want to account for the debug artifacts because anyways that is not used by your real users, right? And you also want to be as close as your release builds. So you either take the release build or you create a profilable build, as Macro Benchmark also suggests in their documentation. Last would be app device-based noise, app/device-based noise. Now, these comes from like various reasons. First one is random GC triggers. So while you are executing the iterations, we have seen that randomly GC triggers sometimes, and if it triggers for some of the iteration, it can really skew your results up. So you want to ensure that things are consistent in all the iterations. Otherwise, you are going to have noisy results. Then it is, this is about system dialogues which are thrown in case of crashes and ANRs. When you are doing a performance benchmark, you don't want to fail your test case just because it has crashes or ANRs. So at mobile.dev, what we do is we first ensure that the app is healthy enough to conduct a performance benchmark. Otherwise, we will cancel all the incoming performance analysis. Otherwise, like it's no point to test performance for a crashy app or like app with ANRs, right? And things like CPU frequencies, you also want to ensure that if you are benchmarking on real devices, you will lock the CPU frequency. Otherwise, it could really happen that CPU can start throttling and things could be really slow in some of the following iterations. And in general, CPU and runtime optimizations are also are scary to just like skew your results. So one of things which I remember is that when your device battery goes down, it is really possible that either it will just stop using one of the CPUs or lower down the CPU frequencies for all of the CPUs that your device has. So you want to ensure that you lock it and just get rid of the like runtime optimizations in general and just keep things consistent when you are doing benchmarking. And believe me guys, this thing is never ending. I can like tell you like 10 many things. So what we do at mobile.dev, we try to keep things consistent in the benchmark because believe me, noises will not end. So you want to ensure that whatever iterations that you conduct, it has consistent environment throughout. When you are also comparing with the baseline has the same type of environment or the sandbox. And another thing which we also do is outlier detection, which is basically to detect, take a snapshot of a state of a device and detect what kind of outliers could be causing like that skewness of the results. So yeah, tool selection is going to be mobile.dev. I have personally seen like our clients using it, and they really see that things which are entering on master branch are visible through the type of results that we show to them. So till now, what we have eyes on the changes that are entering on the baseline branch. We know what things are entering there. We know that through alerts, like through like email, Slack, whatever you like, and through the reports like flame graph TIFF and VCS metadata, you would know that what is causing that regression before it gets shipped and interferes with your fixes that your platform team is working on. And with this VCS metadata, you can map back to the team. This is one of the examples where our console basically helps to narrow down on the region that is exactly causing most of the regressions. So this is controlled by the intensity of the color. So this highest red intensity is going to show that this has maximum change and you want to root cause in this particular region. And yeah, that is also marked red. That is not visible, but still that is less than what we see here. So till now, we have production analytics. We see what is happening on production, and we also have quality gates on the baseline branch. Now is the time that we can really think about the fixes, because you can really now like focus on fixes. You need not to care about what is going to enter parallelly when you are working on fixes. Like the cat dog race is basically finished. So now what we'll do is we'll extract the impacted sessions and collect the traces from production environment, from the impacted sessions. So mark this word, impacted sessions, what this impacted session is. So impacted session for an app launch time, it is defined as like more than 5 seconds by Google, by books. And because there were different spans possible, another thing that you can do is you can reach out to your product managers and you can discuss about thresholds, what you can keep, because definitely if you go beyond that first screen run time, it can go beyond 5 seconds. So you can consider different thresholds for different spans. Now, what you'll do is, since you have the data from production, you'll query the impacted sessions in a way that, like, for example, you'll get data of a user whose 80% sessions are impacted. Like, let's say if he launched or if she launched an app 10 times in a day, and out of those 10 times, 8 times the user faced like more than 5 seconds to complete the app launch. It is going to be impacted session. And the tool selection for this is going to be Firebase real-time database, Firebase user properties, and debug API. This comes with 2 parts. First part is segmenting impacted users. So why we want to segment impacted users? Because you really don't want to trace for every user in production, because tracing is going to cause observer effect. Like when you trace things, it is going to increase the time of the whole interaction. So you really don't want to interfere with every user that you have. You want to just target on the user that are impacted most by your app launch time. And this is going to be possible by Firebase, first by Firebase user property. You will create a user property profile app startup. And with real-time database, what you are going to do is dynamically control this behavior for a specific user ID. So for example, there is this user's schema, and this user schema will have user IDs. And for example, there is like a feature A, which is already enabled for this user ID 1 and 2. You are going to put profile app startup as true and dynamically control this in your app and enable it dynamically for user ID 1. And you are going to enable tracing for this particular user and for the users which you are going to query from the BigQuery. And to conditionally turning on the feature for this particular parameter, what you'll do is you create a parameter, and for a particular user property, you are going to turn this feature on. And by default, it is going to be off. So you are really just targeting that segmented user population which is impacted, and not really studying like each and every population traces. So the second step now here is to upload the traces, because now we have enabled it dynamically for the users. Now is the time that you upload the traces for the impacted users. This is going to be possible by debug API. And what you are going to do is, with the same abstraction that you have, you will check if the feature is enabled. You start the method trace sampling, save the stop it, and then save this trace in your file cache or wherever in the app cache that you want, and then upload it through periodic work manager with some periodic interval. And the upload can be possible by Firebase storage or multi-part API upload. I have personally done it with multi-part API upload. Now, after this, what you will have, since you will have like production traces, you can directly import it to your Android Studio profiler, and you will have traces from production, from the impacted users. And what are we going to do with these flame graphs? And what advantage we have with these flame graphs, because we can anyways do that in local, right? But now the thing is that we have this from impacted users, and this is going to be very useful. Why? Because first of all, you are going to study about the consistent issues that you have on production, and that is affecting most of the impacted users. And second thing, it is going to be possible to create a priority list. So what I mean by priority list, first of all, if you see an issue being there in let's say 5 flame graphs that you get from production, it is very much possible that you are going to chase it first according to the time that it has, let's say 1 second. So it is going to be possible to just prioritize it with other fixes, other issues that you see in the flame graphs. So first you were able to point out the issues that you want to chase. Now you can also try to quantify the fix that you that it will take to fix that issue. Like for example, it could be a refactoring, a huge refactoring. It could be upgrading like library. It could be as simple as executing things at like background thread. So you want to, the principle that I have personally followed is that you want to quantify with these two terms, like first of all, the performance gain that you will have, and also measure the effort it is going to fix. If you will have more performance gain and the effort that is going to take like for a fix is very easy, you just do that. So it is going to be easy to prioritize things. Now, the step 4 which this team did to fix like the issues which they saw on production, they were as follows. DexGuard, it was introducing like encryption. So when the class encryption is on, what happens is it will decrypt it, then load the class, and then initialize it. So if you are encrypting some of the classes in the cold start interaction, it is going to create like a real problem. So you want to keep an eye on DexGuard, what it is doing to the classes. You don't want to encrypt like every bunch of class that you have in cold start. Then like as counterpart of what we were doing in like randomly profiling locally, what you have now is, since you have production traces, you can really see which of the SDKs are taking more time and create a list, and you can like account for it, send them to background thread, and exactly create concrete list of those SDKs. And another thing was that there were some unwanted dependencies which now they were able to finally point out that were getting injected through the Dagger graph, because when people are really dealing with Dagger, they just want to compile their project. They don't really care about where the dependencies are coming from. So you are going to point to exact unwanted dependencies as a platform engineer. Now, as soon as they fix these 3 things, because the fixes were like merely about like one line change. Like for Dagger, it was putting a @lazy annotation. For SDKs, it was background thread, and for DexGuard also. And with that, they achieved like 8 to 10% improvements. Now, the conclusion which I will give here is that, believe me guys, this is possible, that observability is the most difficult part when you are solving for a performance issue. You really do not want to just directly jump on the fixes, because fixes can really be like one line change or upgrading a library. So just concentrate on creating observability, because if you are not going to chase the right metric, you are anyways going to be leading in like a wrong direction. So let's revisit our patterns and let's see if we have solved for them, the patterns that we discussed in the very beginning, right? First one was that the scalable code base was, what the hell? Yeah. Okay. The scalable code base was not high performing code base. Now with tools like mobile.dev, since you have visibility on your baseline branch and you have quality gates in like very less noisy results, you can say that the high performing code base still can be a scalable code base which can get you a revenue. And next thing, because you were getting reactive reaction through customer tickets and through Android Vitals, it is not now no more that case, because now with the quality gates, there is going to be minimal things which will happen like in 1 or 2 devices that are going to be there from customer tickets. The next thing was prioritizing, which you can now handle since you will have exactly the impacted data. You can really now prioritize it accordingly with, like, let's say you saw like 4 issues, then you will know that, yeah, this 4 issues we have to solve for the fix that it will take to gain this performance. The last thing was drafting OKRs. So here is a proposal. It can be a bit disputing, but I'll try to keep it like my view on this. So my proposal is that, first of all, don't do that, like reducing cold start by 80%, reducing battery by 30%, and like just random numbers, because you are not sure what is happening in production. So first of all, you want to create list of metrics that you want to chase, because that is going to define the direction that you will take. So for example, for cold start, it was first screen name, it was app launch time, and it was user ID. It could be different for battery, it could be different for native crashes. So you want to sit back, you want to take time, and you want to define what metrics we are going to chase. Then you are going to create a percentage accuracy on the fixes, because it is really possible that all the fixes that you attempt, they are like all the fixes will not work. Like if you attempt like 10 fixes, all the 10 fixes will not work. So just try to target like, okay, out of 10, we'll try to see that if our 7 fixes would work. And you try to improve this percentage, because KR is just about tracking the productivity of developers for a product team. So you can show this number that, yeah, we targeted for 70% and we saw this time, this quarter, we achieved 60%. In the next quarter, we achieved 70%. So it is going to be much practical. And the next thing which is possible, which you want to really care about, is quality gates. Because if your quality gates are compromised, then you will be compromised from the other feature work. So you want to ensure, if this slides work, yeah, you want to ensure that you have high confidence on detecting like noises while benchmarking and what is entering on your baseline branch and detecting regressions. So with that, I'll finish. Thank you.